Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Azab. So for today, me and my group will present about our data set, which is electricity generation monthly from January 2018 to June 2023. So for the introductions, electricity is vital for modern life, which is it will powering homes, industries, and it is also contributing to a country economies. So understanding its generation and distribution, it is important because for infrastructure assessment. So this report it will analyze Malaysia electrical system using data from the CSV file that obtained from data.gov.my. So this data contains monthly statistic on total supply, public installation, private generation, and also imports from other countries and distribution from 2018 to 2023. So this report also aims to provide an overview of key trends and patterns in Malaysia's electricity sector from January 2018 to June 2023, detailing production and consumption conditions.
My name is Muhammad Danish bin Nurhan, and this is our problem statement. Dominican Republic generation. The electricity supply heavily relies on public installation over 98%, with minimum contribution from private sources around 1%. Next, limited the diversification. This creates a concentrated energy supply structure, potentially lacking diversification. Next, underutilized private potential. Despite flu- despite fluctuation in overall supply, private generation remain consistently low, stressing on untapped resources. Lastly, resilience concerns. This real this reliance this reliance raises questions about the long-term resilience, efficiency, and adaptability of the electricity system to future demands. For our objective, firstly, analyze electricity generation data to understand the dynamics and contribution of public installation, private installations, and imports to the total electricity supply. Next one, identify patterns. To identify patterns within the generation data. Next one, assess reliance. To assess the current reliance on public generation. Next one is explore diversification. To explore potential opportunities for enhancing energy source diversification. And lastly is enhance resilience. To enhance the overall resilience of the energy supply system. And this is our dataset overview. Firstly, we have total supply, represents the total electricity generated. Next, we have total distributed electricity, which is to detonate the total electricity supply to user. Next one, we have local generation public installation, which is electricity generated by public power plants. The next one is local generation private installation, which is electricity generated from private sector. And lastly, we have import, which is electricity imported from other countries.
Okay, for descriptive analysis, as we can see from the table, the sum of total supply is 900 to 21,700 million kilowatt hours. The average is 13,965 million. For local generation public, the sum is 909,437 and for average is 30,779. For private installation, the sum is 12,165. For the average is 184 million. Lastly, for import, the sum is 159 million, and the average is 2 million. For total and for mode, the mode for total supply and local generation is unknown because the values in the column is uh, not duplicate other than imports and private. Okay, next. Okay, next for correlation analysis. The for this correlation, the values range from -1 to 1. The values which is closer to 1 indicate the strong positive relationship, while values closer to -1 indicate a strong negative relationship. Uh, for the strong connection, the as you can see from the table, it is total supply, public generation, and total distribution, with the correlation values all above 0.99. For the others, which is private and imports, the value is quite low, uh, which public generation is 0.04. Okay, next. For the this is the type of chart. Firstly is bar chart. Uh, the this bar chart, for the horizontal axis, it represents the months, while the vertical axis is the total of the sum of total supplies in millions of kilowatt hours. Uh, from the bar chart, we can see the blue color from the chart is 2018. The yellow one is 2019. The dark green is 2020. The blue is 2021. Purple is 2022, and green is 2023. For 2023, it as a data until from January until June only. Okay, next, which is radar chart. The chart is for some of local generation private installation. Okay, from this chart, uh, the 2020 stand out with the highest value of private generation, reaching 2,352 million kilowatt hours. 2022 also shows a significant contribution at 2,258 million kilowatt hours. Conversely, 2023 recorded the lowest amount of private generation in this dataset at 1,128 million kilowatt hours. Okay, next.
So next, this is others of our chart of data. So for pie charts data with the title of sum of imports in million kilowatt hours, it shows us how the total electricity imported into Malaysia, and it is divided up among the years from 2018 to 2023. So each slice of the pie represents a different year. So the bigger a slice, the more electricity was imported in that particular year, and the percentage on each slice tell us its exact share of the total imports. So by looking at the charts, it is clear that the amount of electricity imported varied quite a bit from a year to year. So it not always the same. For the 2020, it is actually had a biggest share of the imported electricity with a value of 43.9% of the total. So this is means that it is a really significant amount of electricity that came from imports that year. So for other years like 2018, it was the second highest with a value of 35.9% of the total imports. Then for 2021, it contributed 33.7%, while 2018 had 25%. So for the lowest imports, which is 2022, it has the smallest percentage of imports, which is 3.2% of the total. So this tells us that Malaysia relied very little on the imported electricity in that year. So in summary, this pie chart show us which years Malaysia imported more or less electricity from other countries. So it is also giving us a good idea of how much we depend on outside electricity each year. So next is the line chart with the title Private Installation versus Public Installations. So this line graph, it shows us the total amount of electricity generated each year in Malaysia from 2018 to 2023. So it separates the power made by public power plants and also the power made by the private sector. So for the y-axis, it tells that the total electricity generated in million kilowatt hours, while the x-axis shows the year. So the blue line represents the electricity from public installations, while the orange line, the blue line is the private installation, while the orange one is the public installations. So we can see a huge difference. Public power plants consistently generate way more electricity than the private ones. So every single year on this graph, public generated more electricity. So for public generations, it the line stayed pretty steady from 2018 to 2022, with a value usually around 160,000 to 170,000 million kilowatt hours. But then we can see from 2022 to 2023, there's a really sharp drop going below 100 million kilowatt hours. So this big drop is basically for 2023, the data obtained was from January only to June. That's why it have a big gap, big drop. Now for private generations, it's almost flat at the every year, and we can see it located at the bottom of the graph because their contribution is much smaller compared to the public generations. From 2018 to 2020, we can see that private generation stayed around 2,000 million kilowatt hours per year, with only small change. But then in 2023, it also shows a slight drop. Again, that is because the data is only from January to June. So in conclusion, this graph clearly shows that public power plants have been the main source of electricity in Malaysia from 2018 to 2023, while private installation contribute much smaller but still consistent amount. So both types of generation shows a big dip in 2023. That's just because the data only have from January to June. So next, this is a bar graph called total versus public, which is total supply versus public installation. So this graph, it helps us to see how Malaysia's total yearly electricity supply compares to the electricity made by public power plants from 2018 to 2023. So from this chart, total electricity supply and the electricity from public power plants are very, very closely related. The blue bars, which is for public generations, it always just a tiny bit shorter than the total supply. So this tells us that public power plants are the main source of electricity for Malaysia's total supply. So as you can see from 2018 to 2022, both total supply and public generation stayed really high and pretty steady, usually around 160,000 to 170,000 million kilowatt hours each year. But then 2023, it also have a big drop because of the data that obtained only from January to June. Next, we move to ML regression, which is regression line. So for the first regression lines, by looking at this graph, we can see a super strong and clear connection between the electricity made by public power plants and the total electricity available. Uh, as you can see, the blue dots, which is it represents actual monthly data points. It is really close to the regression line. So this type grouping means there's a very steady pattern when public power generations goes up, the total amount of electricity supplied always goes up right along with it. So it really shows how strongly connected they are. So the orange line, which is the regression lines, it is really important part of the graph because it's like a simplified picture of the strong relationship. Its steep upward slope clearly shows that public generation has a huge impact on the total amount of electricity. So, in simple terms, the more electricity public power plants produce, the more electricity is available overall in the country. So, the fact that all the data points stick so closely to these regression lines, it tells us that public generation is one of the main source of the electricity in Malaysia. So next we move to second regression line. So as we can see, compared to what we saw with the public generation, this graph shows a much less clear relationship between the electricity made by private sector and the total electricity supplied. So the blue dots also represent a data monthly. So as you can see, the blue dot is quite spread out around the orange regression lines. So even though the line itself has a small upward slope, this slight upward slope suggests that when private generation increase, so the total supply that generated also increase. So however, because the dots are so spread out, it means that private generation is not as good at predicting the total supply as public generation is. You can see that private generation might be at certain level, but the total supply can still vary quite a lot. So for the centroid represent as the average of both data sets, which is it is located on the regression line. So it shows that the line goes through the middle of the data. So what can be concluded from this graph is it shows us that even though private power plants do add to the total of electricity supply, their impact is not as direct or easy to predict in a straight line as public power plants. And last, for the third regression line, So this graph shows the relationship between how much electricity Malaysians that import from other countries and the total supply in million kilowatt hours. So when we look at the graph, we can see a very weak connection between how much electricity we import and the total electricity supply. So it's not a strong linear relationship at all. So the blue dots, it really spread out around that orange regression line, just like we saw with private generations. So the line itself has a tiny upward slope, which is it's shows that when the import increases, the total supply might slightly increase too. So we can notice that blue dots are spread near the left side of the graph, which is close to zero imports. This means that for many months, Malaysia import very little or no electricity, even during these months with low imports. The total supply still varied quite a bit. So this wide spread of point tell us that imports don't really predict the total supply in strong, consistent way. So what can we conclude from this graph is it shows that while electricity imports do add to the overall supply, their impact is not as direct or easy to predict compared to the public generation.
So this is our decision tree model. This model is built to predict a certain target value, possibly related to energy or electricity consumption, based on two main features, which is public generation and total supplies. So at the top of the tree splits first based on whether public generation is less than or equal to 13,772.8. From there, it continues branching based on threshold values of public generation and total supply. At each node, the model calculates the average target value and the square error to assess prediction quality. As we move down the tree, the data becomes more specific and the error typically decreases, which improves the prediction accuracy. In the leaf nodes at the bottom, we get our final predicted values. For example, if public generation is less than or equal to 1200 367.05, the predicted value is around 11,891.3. Each path represents a decision rule that the model follows to make its final prediction.
Okay, next for the things about data. Okay, this is the coding for the things board. Okay, after I run this coding, the things board will show the result of the all chart. Okay, as we can see in line chart, this represent the local generation public and private
Faris,
installation in million kilowatt hours. Uh,
Faris.
for the blue is the local generation public, and for the green one is local generation private. Okay, next for the point chart, it represents the import uh, in million kilowatt hours. Okay, for the bar chart, it represents total supply, imports in million kilowatt hours, local generation private and public, uh, local generation private and public installation. Okay, for pie chart, it represents local private, local public and imports. As we can see, the local public has 99%, uh, for private is 1%, and imports is 0% because the imports value is 21.9. For local private is 185.3, and for local public is 14,722. Okay, uh, this two is range chart and the power consumption card, which is represent the total supply of the total supply in million kilowatt hours.
Okay, in conclusion, the model highlights that electricity supply is still heavily dependent on public installation, while private sources and imports contribute only a small fraction. This reveals a concentrated energy system where the majority of generation comes from a single sector. Such concentration underscores the importance of diversification. By understanding, by understanding these dynamics, policymakers and planners can explore new strategies to build a more resilient and balanced energy system, ensuring long-term sustainability and energy security.
So that's all from us for our presentation during our mini project. Thank you.